Okay, so today we're going to be talking about mid segments, okay? And we're going to focus on that. There was another term we're going to talk about, and also I'll introduce that first, then we're going to let it go, okay? So let's start by doing a median, okay? So a median, okay, on a street, is in the middle, right? Okay, and so the way that you find a median is you find the midpoint of one side, okay, so find the midpoint of one side and you connect it to the vertex across from it. So that would be the median of that triangle, okay? It bisects the side. And so I can find the median from any side's perspective. So if I find the median of VQ, I find the midpoint and I connect it to the vertex across from it. So that would be the median of VQ. Okay, and I could do it a third time. Every triangle, you can do it 3 times. Find the median of a side and connect it to the vertex across from it. Okay, and I didn't draw a very straight line, but those are medians. And they're going to meet in the middle, okay? And the middle of that intersection point is called the centroid. Okay, so the centroid is where the 3 medians meet. Okay, and it's always inside the triangle. And so I'm going to talk about that and I'm going to let it go. Okay, so we can find a median of a triangle, just like you can find the median of a street. Okay, how do you do it? You find the midpoint of each side and you connect it to the opposing vertex. And then the centroid, okay, it sounds like a strange alien, is going to be where those 3 medians meet. Okay, so that's going to be a vocabulary piece that we talk about. But today's main lesson is about mid segments. Okay, mid segments involve finding the median, but you don't connect it to the vertex across from it, you connect corresponding medians. Okay, so it's a little bit different. Okay, and so think about this. Okay, let's go up to this top problem and say, okay, if I want to find the mid segment, okay, we can find it 3 times in every triangle. How you do it is you find the midpoint of 2 sides and you connect them. Okay, you don't connect it to the vertex, you connect 2 midpoints together. Okay, and so the beauty of it is that the 2 lines that are formed, not the 2, but the line that's formed is going to be parallel to the base below it. Okay, and so those 2, and also numerically speaking, it'll be half the size of the base that is below it as well. Okay, so that's kind of cute. And so again, we can do this 3 times in every triangle. So if I find this midpoint here and this midpoint here and I connect them, okay, first of all, it's going to be parallel to this side here, and it's also going to be half the size of that side, the segment across from it. Okay, so that's kind of cute. And then I'll do this with yet another color. If I find this midpoint, these 2 midpoints and connect them, it'll be parallel to the side that is going to be below it, or like the side of the triangle. And then also to be half the size of that side of the triangle. So, and then additionally, do you see that if I find all the midpoints and mid segments, then I'm going to form 4 triangles, and 3 of them will be congruent. Okay, so this one is going to be congruent to this one right here, and this is going to be congruent to this one here. So these 3 will be corresponding and congruent to each other. Okay, and so that's kind of cute. All their segment lengths will match, all their angle measures will match. Now, actually, the middle one also is congruent, but it's been flipped over twice. Okay, and so you can see if you can kind of flip it over twice, it's going, or rotate it, okay, it's going to be actually a 4th congruent triangle, but it has been rotated or flipped over twice. So you can think of it either way. And so as we do these mid segments, we're going to be talking about the angles formed in each triangle, and then also we're going to be talking about the corresponding side lengths as well. Okay, so the 3 main triangles will be congruent to each other, and they're going to be half the size of the original triangles, while their lengths will be, their angles will match the original triangle, and we'll talk about what that means as well, but the middle one is going to be reflected twice or rotated. So just kind of hold on to that in your heart. Okay, so let's go to some numerical problems. Okay, so let's look over here. So they made some mid segments, okay, meaning they connected the midpoints of 2 sides. And so we're saying, okay, given those measures as shown, can you find the appropriate measurement? So we have to find XZ. Okay, well, if we know this bottom is going to be equal to 13, well, then what do we know about the parallel line here? Well, it's going to be half the size of it. So that's going to be 6.5 units. Okay, so we can write 6.5, we should always label, and that's going to be units. Okay, a length is in terms of centimeters or meters or inches or units, etc. Okay, and then ST. Okay, well, ST, where is she? Okay, I see her. We've got, if this is 7, okay, and then this length right here is going to be twice as long. So that'd be 14. Okay. And so each of those two pieces of ST are going to both be 7. Okay. So all three of those are going to be the same. So this overall length will be 14 units. So you can write 14 units here. Okay. ZT. Okay. Where is ZT? Oh, ZT would be 7 units. Okay. Okay, because it's a midpoint. So Z bisects that segment into two pieces. So each of those pieces will be 7 units. Okay, now to find the measures of these angles, okay, the thing is that what we've got to remember is when we have mid segments, we've got parallel lines formed. And so therefore, we've got alternate interior angles that will be formed and say, corresponding as well. So let's look and see what we've got going on to find RYX. Okay, RYX is going to be, our y-axis is going to be right here. Okay, so let's look at it. If we know that these two lines are parallel, okay, can you see that the angle we're trying to find is going to be alternate interior angle with 124 degrees? Can you see that this is the transversal here? And so these two angles have to be congruent. Okay, alternate interior. So if you've got parallel lines cut by transversal, alternate interior angles will be congruent. So this will be 124 degrees. Okay, so holding on to the fact that, your transversals, if those rules are still true, we can see that that's going to be the truth. Okay, let's try the next part. We've got to find TYX. Okay, so TYX. Okay, well, she right here is going to be this. Okay, well, that's not going to be too bad. Those are a linear pair. If we've got 124 is going to be our first angle, this blue one, well, then the pink one to the right is going to be 180 minus 124, which will give us a measure of 56 degrees. Okay, by the linear pair theorem. So this angle here is going to be 56 degrees. Okay, the next thing is XZ. Okay, X, that's hard to say. XZS up here. Okay, well, all right, I can see that. Do you see that we have parallel lines? Okay, we've got a transversal here. And then we also have these two lines are parallel to each other. Okay, so if we want to talk about corresponding angles, okay, well, these two angles right here will be corresponding. And then also, if we've got two more parallel lines cut by a transversal, then these two will be corresponding. So therefore, transitive property says that those two angles are going to be congruent to each other. And so therefore, it's going to be 124 degrees. We could have also looked at, if you notice that this line here is parallel to this line here, and so this is the transversal going through it, well, then these would be alternate interior angles as well. And so they'd both be 124 degrees. So that might be a more direct route as well. So by parallel lines, and when you've got mid segments, you've got a lot of parallel lines and transversals, and then alternate interior angles will be congruent. So that would be 124 degrees. So this will also be 124 degrees at the very bottom. Okay, awesome. Okay, let's find each measure here. Assuming we have found the mid segments, okay, and mid segments are parallel to the side that's below it, okay, and so the side, and so DE, let's find the length of that. So DE is where? She's right here. Okay, well, we've got DE that we want to find, but we know this is 15. Well, half of 15 is going to be 7.5 units. Okay, good. And then DB, okay, DB, well, that one's right here. Okay. Okay, well, look at this. So this segment here is parallel to this one here. That's mid segment. And we know this is 9.2, FE is. And so therefore, this will be 9.2, this will be 9.2. And if you want to find the overall length, it'd be 18.4. So DB is just 9.2. Okay. And then we've got to find the measure at FED. Okay, where's FED? FED is right here. Okay. This might take a little bit more manipulation. Let's check and see what we know. Okay. No, that's not going to be too bad. Okay, if the two green lines are parallel, do you see that these are alternate interior angles? And so Fed is going to be also 82 degrees. Okay, so alternate interior angles. So if two lines are parallel, yeah, cut by the transversal. The transversal is DE. Alternate interior angles will be congruent to each other. Okay. All right, here's a couple more. Can you find the measure of the things they ask you to find? And so I think the first one's pretty straightforward. It's going to be 15 units because these two are parallel. And this is the mid segment. It's going to be half the length of the parallel line to it. And then FD, let's check this out. EC, they tell you, is going to be 15. So if this is 15, this will also be 15 because they're midpoints. E is the midpoint of that segment. And then FD will also be 15 centimeters. Great. Okay. Down here, we got to write a cute little equation. There's a couple ways you can write it. Okay. And so now these two segments are not going to be congruent. Remember, the shorter one is going to be half the length of the other one. So if we want to write an equation, there's a couple ways to think about it. But one way is to say 3x plus 1 is equal to half the length of the parallel line to it. So it'd be 55. And so we can solve that equation by subtracting 1 and then dividing by 3. And you get the answer for x to be 18. And so that will be our answer. The next one talks about the measure of the angles. And so I think we've got to think about, remember, we've got 3 congruent triangles that are all face up. Okay. And so we can use that logic to say, okay, if I know that these 3 triangles right here are going to be congruent, which means their sides are matching and so are their angles, then we know that the corresponding parts will match. And so we know that over here, this will be 44 degrees. Okay, and so by the triangle sum theorem, we know that x plus 76 plus 44 is equal to 180. If we subtract 76 and 44 from both sides, we're going to get this measure to be 60 degrees. Okay, and so that will help us to do that. So it'd be 10, and the other, check and make sure my math is good, 7. So it'd be x plus 120 is equal to 180. So it really does have to be 60 degrees. So, if the triangles are congruent, then their corresponding parts will be congruent. Okay, and so the corresponding angles will be congruent as well. Okay, so down here, they give us a lot of stuff. They tell us that, and we should label it, but it's sometimes hard to put it on the diagram and not mess yourself up a little bit to be like, all right, what is going on? So HJ, okay, HJ, so this bottom part right here is going to be 46, okay? And then also, I don't know where I got that. GH is 46. Let's rewind the ship just a little bit. Okay. Rewind this a little bit. Okay. Let's actually read the letters. Okay. So we've got GH. Okay. So this side right here is actually 46. Okay. So since W is the midpoint, the two segments are going to both be 23. Okay. And then, so does it ask us what Vx is? Yeah, it does. So that means Vx is going to be 23. Okay, so half of that. Okay, so we might as well get that done. Okay, and then it tells us that VW is 27 inches. So let's write down that. VW. Okay, so this part right here is going to be 27. So that means this overall bottom is going to be 27 plus 27, which is going to be 54. So let's see what they ask us about the bottom. Do they ask us HX? No, they do not. Do they ask us anything about that one? I don't see it right this second. Okay. JX, no. Okay. And then the other thing they tell us would be that VJ is 30. Okay, so VJ being 30. VJ, this is 30 right here. So if this is 30, that means this is 30 and so is this. Okay, so those three pieces are going to be all 30. So in that vein, they ask us what WX is. So we're going to say that's 30 inches. Okay, and then let's look and see. HJ is one thing they ask us. So HJ is 54. Okay, we know that. That's the very bottom, so that's 54 inches. And then they ask us GJ. So GJ is going to be, oh, that whole side, so that's going to be 60. So it's that whole side along the right. Okay, so that's 60. So I guess working with, parallel segments are going to be, have that congruence or double or half of it. Okay, and so now the angle measures. Okay, so I think what we need to do for that is I probably should erase what I have on the diagram, and let's just focus on the angles that we see. Okay, so I'm going to erase this. And okay, my eraser is not the best, as you can tell. And so what we can do is we can say, let's label what we know, WHX. So WHX is right down here, and she's 92 degrees. Okay, a little bit bigger than 90. So it's 92. And then V or WXV. So W and then X and then V, this is going to be 30 degrees right here. Okay. So this is 92, and I should erase that and fix it a little bit because it's kind of disgusting. Okay. So 92 right here. 92. And the thing is that we can tell, like, those three triangles are going to be congruent. So these corresponding angles will all be 92, okay? And then the problem is that middle one is kind of reflected and stuff like that. And so if this is 92 right here, and I'm going to put a little arrow, that's 92 degrees, we can easily find this measure right here by subtracting 92 and 30 from 180 to say, okay, well, then that means that this is going to have to be 58 degrees. Okay, the linear pair theorem states that the sum of the line angles are going to be 180 degrees. So if we know corresponding angles are congruent, and then we've got that. We also have some alternate interior angles that we might use, but at this minute, we're going to use triangle sum theorem, and we're going to also use the linear pair theorem. Okay, so the question is, they want us to find GWV. Okay, so GWV, oh, that's going to be just right here. So that's going to be 92 degrees. Because of corresponding. Okay. The second thing is they're going to ask us probably a harder question, XVJ. So XVJ is going to be up here. Okay. So let's see if we can come up with that. Well, the truth is we just found this bottom right angle to be 58 degrees, didn't we? Okay. It corresponds with this angle here. Well, by the triangle sum theorem, if we know the left angle's 92, the right angle's 58, by the triangle sum theorem, we can subtract those from 180, and we're going to get 30 degrees up here. Now, notice we really only have three angles we're working with, don't we? Okay, 58, 92, and 30, because we knew there's one angle here that they gave us at 30 degrees, and all four triangles are going to be congruent. And so I betcha, okay, if we did the math using the linear pair theorem, we would find this, all three angles in there to be 92, okay, and then 58, okay. And so all four triangles are going to be congruent. It's just a matter of, can you reflect it twice to find the middle one, or can you use alternate interior angles? Yeah, if we did, let's look at this together. If we did, these two lines are parallel because we know they are. Well then, and if this is your transversal, we know this angle is going to be 92, don't we? These two angles will be congruent to each other. And so, so that will be 92. We could also figure using the linear pair theorem or using some other alternate interior angles. I betcha we're going to find this to be 58 right here. Okay, so all three triangles will be congruent. We just have to use some of our math knowledge of alternate interior angles or using triangle sum theorem or the linear pair theorem to solve the triangles that you see. All right, well, thank you so much. I hope you have a great day.